Hi there. In this video, I'm going to talk about gRPC to give you an overview of this awesome interprocess communication protocol for modernizing remote procedure calls. So let's get started. First of all, what is gRPC? gRPC is a modern high performance remote procedure call or RPC framework used for interprocess communication. So, interprocess communication means you have one process running in a machine, another process running in the same machine or in a remote machine. And if you have a requirement to have some data exchanged between these two processes, the mechanism that you use to exchange those data is done through something called an IPC, right? Interprocess communication. So there are various ways to do that. This became very popular when BSD or Berkeley sockets was introduced by BSD way back in 1970s, and TCP/IP was born at that time, and interprocess communication became a reality from that point onwards mainly. So there have been various other RPC frameworks on top of TCP and other protocols like UDP and so forth. And gRPC is one such protocol that works along with HTTP as well. So basically, HTTP 2, which is a network efficient protocol, the version 2 of the HTTP. HTTP is an application level protocol built on top of the TCP/IP stack, either on TCP or UDP and so forth. So HTTP 2 is based on a bidirectional binary protocol based on TCP, right? And HTTP 3 version is also there, and that's mainly based on the UDP protocol. So you can have these application level protocols working on different other protocols in the level layer 4 of the uh, you know network stack usually. So usually those are called L4 protocols. Anyhow, gRPC is based on HTTP 2 mainly by default, but that does not mean that it cannot be used on top of other protocols as well. You can think of it as like by default uses HTTP 2, and it supports bidirectional binary messaging protocol for performance reasons, and it also uses protocol buffers, which reduces message size when it comes to transferring data from one node to the other. And protocol buffers are used as the interface definition language. Now, when it comes to a server or a service which needs to be invoked by a client, a service should tell what does it actually expose as part of the service, and that is defined mostly in various technologies in using some sort of a definition language. Now, in gRPC world, this definition language is based on protocol buffers, and that's usually called uh, an interface definition language. So gRPC was first released by Google back in 2015, and that was however, that version was not the 100 version. 100 version was released in August 2016, and all of this release stemmed from a Google internal framework called Stubby, which they had for a very long time before they released gRPC, and it was primarily more C++ centric at the time. So when Google thought they wanted to open source this technology and make the wider community start using the technology, they were thinking of various options, and they soon understood that they could not release Stubby as it is, or as it was at the time. So they thought of, okay, having a complete relook at the concepts of Stubby and take the core part of it and make it more accessible to the community. And they made it a language agnostic framework, and gRPCs today as such that you can use various different programming languages to write your gRPC clients and services. And on a very high level, this is what it looks like. So how do you write a gRPC service? And you start with your interface definition language using your protocol buffers, something like, let's say, customer.proto. And once you have that file that is called the service definition, you will generate a service skeleton, which will be the starting point for somebody to create their gRPC service. With that service skeleton, the developer will be implementing the service logic. And once that logic is there, they can run it. And with the same interface definition language, on the client side also, somebody can generate a stub for a gRPC client. And of course, once they have that client stub generated, and that is supported with various different programming languages, an application can use that particular stub to make a gRPC call or a remote procedure call, just like they are making a local call. So that's what usually an RPC framework always does. So you don't really need to know how the underlying technology works, or underlying transmission is happening, transferring is happening, what protocol is being used. Obviously that information is useful for anybody to know, and that's exactly what I'm trying to do in this uh, presentation. However, as a client application developer, once you have the stub, you don't need to worry about those intricacies. You just have to use the methods that's exposed by that client stub to make the call to the service. Obviously, you need to pass the relevant information, like if you want to get some information out of the service, and you might have to give something like a customer ID. Or if you're creating a new customer information on the server side, or on the service side, maybe you need to provide the details of the customer. And all of what you need to provide is embedded into that client stub. And all of these details are usually captured in the interface definition language in your protocol buffers. And that's how the communication happens. And underneath, when that client makes the call to that particular function, behind the scenes, the client creates a connection with the service using HTTP2, and then the communication starts using the bidirectional protocol that HTTP2 is, right? So that's the high level of gRPC. But what other IPC techniques or technologies were there and are there, right? And when we get to hear about the RPC and interprocess communication frameworks, obviously TCP/IP and TCP raw sockets is one definite IPC mechanism. But we are talking about the frameworks here, so not just the raw sockets and so forth. So one of the frameworks that was available in the late 90s, or from mid 1990s to late 1990s, is this technology called COBA, or Common Object Request Broker Architecture. And I am honestly haven't looked into it, but I have heard of it. I haven't done any coding on that side, but I know that it existed, and it predates the other technologies that you see beneath. And if you want to know about it, maybe you know uh, you can find more details in Wikipedia and other materials that are out there. So that's one. And another technology that became popular in early 2000s was this thing called RPC, which just stood for remote procedure call. And there were different variants of that, such as barebone RPC, and then you know XML RPC came into the picture, and JSON RPC came into the picture, and so forth. And these are like very common. And if you had been a developer in the mid 2000s or early 2000s, it's likely that you would have come across these technologies and have might have had some experience with it. And then in Java world, they brought in this technology called RMI, or remote method invocation, particularly that is in Java. And in .NET world also there is actually something similar called .NET remoting. I haven't included that here, but that is also an IPC technology. And all of this paved the way to, especially the RPC and COBA, paved the way to this other technology which became very paramount for web services, is something called the SOAP. It initially stood for Simple Object Access Protocol, but later on that acronym did not stood for SOAP, right? And the SOAP acronym was not for that, but anyhow, SOAP just meant SOAP, right? And it was XML based and mostly HTTP based. And it's likely that you might still find some enterprises using SOAP for legacy reasons or legacy technologies that they might be having. Some products, vendor products, might still be offering SOAP services and so forth. And however, it was very bulky, and it was based on this text-based HTTP protocol, and there were so many other specifications around web services which is normally mentioned, or uh, uh, mentioned as WS asterisk, right? And those specifications such as WS policy, WS security, WS transactions, and so forth, were adding more to the complexity of SOAP already was, right? So that's one of the reasons that it kind of declined, and REST became popular because REST was much simpler and people could understand it better, and you didn't have to like have compatible implementations of it. So most of the time, doing an implementation on a technology or a programming language was much more easier. But in SOAP world, it became more commercialized, and vendors started implementing it. It didn't become widespread around different other open source technologies. There have been open source products and many ESBs and stuff created around that, but it was all meant for commercialization, right? Mostly. There have been open source ESBs and stuff, but still utilizing and using it wasn't that easy. And REST success relied on that basically. So, and it became widespread because programming languages themselves started supporting it, and creating an HTTP based REST full service was a breeze. And that was the reason why APIs became so popular in the early 2010s and after. And now APIs is what actually fueling digital transformation of various companies. And now with AI into the picture, APIs are something inevitable these days, right? And in that is there to live. And and REST was not strongly typed, and that was one of the problems with REST APIs. And despite its problems, a lot of people are still using it, so that's a different story. So it is not strongly typed, and documentation or creating a definition to force people to start from a contract first approach wasn't that easy. So for you to write a REST API, you don't necessarily need to start with a contract first approach. You can start with code first approach and then finally come up with a contract. But as a good practice these days, people try to look into a contract first approach. This was not possible with SOAP either, right? SOAP, for example, promoted the contract first approach with its WSDL specification. It's a web services description language, just like this ideal protocol buffer based IPC, ideal for gRPC. SOAP had WSDL, right? So it promoted that. However, it was not a necessity. It was not really a necessary thing to follow for you to write a SOAP service. Somebody could just start writing a SOAP service without having a WSDL as well. And so REST, one of the I would say evolution of the REST is the GraphQL, which was invented by Meta or Facebook, which is a query language, implemented on top of REST or HTTP. So basically, it solves the problem of overfetching and underfetching and things like that. Now, in REST world, when you have an application requesting some data, it will respond back with whatever the service intended to respond with. It's not something that client can ask, only send me these particular fields. And if you have such requirement, rest is not going to work, because if server is giving some information, that's all. So it might be necessary for you, or it might be too much for you. So that is what overfetching and underfetching is all about in the REST world. But in GraphQL, that problem is solved, because you can ask for the exact fields that you want, not more, not less, right? So that is basically GraphQL is, right? And gRPC solves the main problems that other frameworks except GraphQL. Maybe GraphQL is also very popular these days, and a lot of organizations are using it. So it's would be unfair to compare GraphQL and gRPC these days, and because they have found their own places in the enterprise, which we will talk about. So gRPC in general is a contractor first approach, right? gRPC follows that, and there is no way that you can write a gRPC service without a contract or without a protocol buffer, right? So that's one thing. Other thing is it doesn't have the complexity of the SOAP with a lot of other specifications and stuff. So it builds on top of whatever that was there, that is there, right? Like HTTP2 and things like that, and no other specification, and other approaches like authentication using OAuth 2, and you know authorization frameworks like those are being used. It doesn't try to solve those problems, and it just tries to solve the problem that it is supposed to solve, which is the interprocess communication. So, what are the advantages of our gRPC? So, gRPC is efficient. It's because it depends on the protocol buffer, which is based on a binary protocol on top of HTTP2. So, the amount of data that it transfers back and forth will be much less, because it's a binary protocol as opposed to a text-based protocol that mostly SOAP was based on, and most of the REST APIs was based on. Now, you can implement REST services using HTTP2 as well, using binary protocol. But but most of the uh, publicly available REST APIs these days are still only supporting text-based HTTP 1.1 based APIs or services, and it is strongly typed as well, because the interface definition in protocol buffer itself is strongly typed, and which is not the case with REST, however, because in even if you use open API specification, open API 3 and whatnot, you still don't have that strong typed capability in there. That's because it was not built with that in mind. So gRPC was built with strongly typed interface in mind, with protocol buffers. And it enforces contract first approach, as I mentioned, and it's already polyglot. Stubby was C++ centric, but the reason that they wanted to do gRPC was because they wanted to make it more language agnostic, and make it available for wide array of programming languages out there. So nowadays you find gRPC capability with all the modern programming languages, and I recently found that they have added support for Rust programming language as well, and it has full duplex streaming, which means you can do data receiving while sending. So full duplex and well integrated with cloud native systems, and most of the cloud native applications now make use of gRPC. And obviously industry has adopted gRPC very well, and a lot of organizations have started using gRPC, and its usage is only going to rise in the next uh, decade or so, I would say. And so that's one of the reasons why you should be fully acquainted with this information, as well as the skill to write gRPC services and clients. Okay, so it's not a technology that, such as gRPC, doesn't have any disadvantages. All technologies have advantages as well as disadvantages. So let's look at some of the disadvantages. And you know the 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 practice in enterprises, the current practice in enterprises, uh, has indicated that gRPC is not really suitable for external facing APIs and services. Like if you want to expose your services to a public or your partner or somebody, maybe gRPC is not the option. Is because they will have to look into the interface definition language, and they have to deal with some of the nuances of gRPC, which for some reason hasn't picked up that well. So this is the area where GraphQL has mostly found its place. GraphQL is mostly finding its suitable in that space, and one of the other reasons is that your clients can be of very different types, like mobile clients, web clients, thick clients, thin clients, and so forth, right? And they have different requirements, and how they want to fetch the data is also different. So that's where GraphQL is finding its place, because some of the clients, like mobile clients, can only request the data it needs, which is not possible with gRPC. So that's why GraphQL may be the right choice there, but not the gRPC. And let's say if you have implemented a gRPC services using your protocol buffer interface definition language, and now you need to update it. A significant update in your service definition might require a code generation, like starting all over again, sort of, right? But the efforts have been made to minimize that. But especially if you make drastic changes in your service definition, obviously it will look like a new service. It's not going to be the same service. So you have to be careful in that side when you write your interface definition language and make adjustments. Those adjustments needs to be mostly incremental, and in such cases making changes in your code is also going to be easier, and you will not have to make drastic changes in your code. And but we'll also need to accept the reality here. The reality fact is that it is still not super widely adopted like REST and HTTP protocol, as right as that. So this is the same situation for GraphQL as well, to a certain extent. But in my opinion, GraphQL's adoption has been little higher than gRPC in that aspect, because gRPC is kind of finding its place in the back office. And if there are any implementations there, it's most probably on the back end side. Right. So talking a little bit about protocol buffers, it is a data exchange format similar to JSON and XML. It's a kind of a serialization format. You can think it that way. Think in that way. So JSON and XML is a serialization format. Likewise, protocol buffers is also a serialization format. The key difference in XML, JSON versus protocol buffer is that XML and JSON are text based serialization formats, whereas protocol buffer is a binary serialization format when it goes on the wire, right? Protocol buffers are strongly typed, whereas XML and JSON are not. Allows us to define the data contract between multiple systems. Obviously, that's what a uh, definition language means, and this can be used to generate code in various languages like classes and functions and so forth, depending on the programming language that you intend to use gRPC with. Some programming languages may not have the concept of classes, some may not have concept of some dialects that you find in some programming languages. Then the way that it generates the code may also be different. And even though the protocol buffers and gRPC is based on HTTP2, you can still use it on top of other protocols. You can even go down to the layer 4 protocols like TCP, or even protocols like AMQP for messaging. Right. So we have covered a lot, and I just want to like quickly wrap this session up with four communication patterns, four popular communication patterns that you find in gRPC. Is one is called the unary RPC, and there is something called server side streaming, client side streaming, and bidirectional streaming. So let's talk through each one of it step by step. So unary RPC is just like the first example that we spoke about. You have a gRPC service and a client sends a request, and the service will respond to that. It's sort of like client, uh, request response type of a communication, and that is what your unary RPC means. Like at a time, you just send a request and then you get a response that might come in at the same time, but even though the underlying protocol is full duplex, but this pattern dictates that you send a request at a time and then you get the response at a time. Server side streaming is going to use more kind of a real full duplex functionality. You send a request, but the response comes in chunked format. It doesn't come in like one full blob, but rather it comes in chunks, and then the client will read those chunks until it finds no further information there, and they collate that information to find out exactly what was sent by the service. Each chunk could also mean a full message. It doesn't say that it could be a part of the message and so forth, right? But that's what the streaming is all about. So you will be having chunks of requests. Client side streaming is the opposite of server side streaming, meaning you will be sending information to from client to the service in chunks or multiple messages basically. And as soon as the first message comes, response might be generated. We don't know that, and that's based on the service logic. It might be that the service waits for three chunks of the message and then collate that information and respond back, or it just waits for all four, or it could start from the first one. So that's the client side streaming. And the bidirectional streaming is obviously the full blown full duplex form, where the client is also sending in streaming form, service is also sending in the streaming form to the client. So this session or this presentation is intended to be sort of an overview for gRPC. I believe you have got some information out of this particular session. So I intend to show an hands-on uh, step-by-step flow on how to create a gRPC service, possibly through Go, a programming language, which is what the gRPC is very popular with. However, you can use it, gRPC, to write your services in Java, C++, Python, and so forth. But we'll come back to you with another session, or another presentation, or another demo with a step-by-step walkthrough of writing a gRPC service and a client. Until then, I'll take a leave now, and thank you very much for watching this video.